All right, good evening. We are working on pre-calculus, and we have a exponential equation here. Um, this is a pretty standard one. First thing you want to look for is to see if 5 can be expressed as a power for 40, or 40 can be expressed as a power of 5. They're multiples of each other, but they're not powers of each other. So if it was 125 or 625, that's the kind of thing we're looking for. That didn't happen. If you can relate them, then an easier way to go might be to get the bases to be the same so that you can equate the exponents. We can't do that. There's no way to say, 5 squared, 5 cubed, 5 to the fourth. It's not going to be 40. So what we're going to have to do is we're going to have to take a logarithm. Now, it doesn't really matter which logarithm you take. You can take a log base 10 for a common log or a log base e for a natural log, whichever you prefer. So I'm going to go ahead and take log base 10 on both sides. So we have log of 5 to the 3x plus 1 is equal to log 40 to the 2 minus 5x. Right? And the whole point of doing this is that there is a rule in logarithms that allows our exponent to come down in front. And it's one of the big rules that we use. So here we have a 3x plus 1 parentheses log 5. Now log 5 is just a number. And this is equal to 2 minus 5x, parentheses, log 40. Again, it's just a number. And what we're going to do is we're just going to distribute this through. Okay, so our first step, take the logarithm. Right? Our second step is distribute. Okay, so we're going to say this is 3x log 5 plus log of 5. That's equal to 2 log of 40 minus 5x log of 40. Okay, our third step is we're going to push all of the x's off to one side and everything else on the other side. So we're going to collect terms. Okay, so really what I'd like to do is everything with an x in it, I'd like to see that on the left-hand side. It could go on the right too, but or the right. It's not going to be both. But I prefer to put them on the left. So we're going to have plus 5x log 40 to both sides, plus 5x log 40 to both sides. And we're going to subtract log of 5 to both sides, subtract log of 5 to both sides. All right. Now let's go ahead and kind of combine terms and kind of figure out what we actually have here. So just take a look at what we have. Okay, take inventory. Take inventory, I guess, or simplify. I think that's really what we're doing. So we have a 3x log of 5 plus a 5x log of 40. What that is equal to, that is 2 log 40 on the other side minus log 5. All right. Notice all of the x's are now on the same side. We're going to factor an x out because each of these is a 3 times x times log 5, 5 times x times log 40. Both of the terms have an x in them. We're going to factor that x out. All right, so we have 3 log 5 plus 5 log 40, and that is equal to 2 log 40 minus log 5. All right, now these are just numbers. They're not zero, but they are just numbers. We can divide by numbers. That's okay. So we have 3 log 5, we're dividing by 5 log 40, we're dividing by that. And then on the other side, we have 3 log 5 plus 5 log 40. And then what we're going to have is this is going to cancel, right? These are multiples of each other. These cancel. So we end up with an x equals, and then here we're done. We have 2 log 40 minus log 5 all divided by 3 log 5 plus 5 log 40. And that would be our answer. Now, I don't know what this number is. I'm sure it's quite delightful at parties, but I don't need to know what it is. That's our answer. It's not zero. We could calculate this out. We have a calculator we can use. We can plug it in there. And then we can verify our problem by plugging the x in for our value and see if we actually get equality for it. But you don't have to do that. You can if you'd like, but you don't have to do it. Right? And that's pretty much how you solve this kind of a problem. So with that, I'm going to say thank you very much for joining us in the video, and I'll see you on the next one. Good luck.